Liking this video will help this channel to grow. So please go ahead and give this video a like. Hello guys, welcome to our 2026 Year 9 End of Year walkthrough. Guys, if you look into this walkthrough, you do it all and you haven't seen some questions on topics you're expecting to see, make sure you watch the last paper 1 and 2 Year 9 walkthrough, in which I've gone even more in depth than I have done in this one, and that's because that already existed. Now, the videos are time coded, so therefore you can skip through if you want to get to specific topics. Also, I've linked in the description of the video the paper that I'm working, and that is good for you to print it off and work along to give yourself that practical experience as well, rather than just watching it as a movie, even though that helps to make things permanent. Okay, so make sure that you do that. Now, before I go on, I just want to stop to make a special shout out at Tina Answer 2349 for active engagement in the comments section, asking question, answering question. And what stood out to me really clearly is the fact that this particular person doesn't only do revision when it's end of year time, they're doing it all year round, asking questions and saying how well these walkthroughs and these videos have been helping. So guys, that's a very good practice to take up as well. So another thing I want to say to you, if you want to shout out, make sure that you comment in the comment section as well and be actively engaged, like the videos and so on, and then you will be mentioned. Now guys, I must confess to you today, I'm feeling blue. I'm not feeling my best at all. I've got a serious issue with a fever, coughing and everything like that. But guess what? I want to teach you resilience. So not because I'm not feeling well, I really wanted to help some people to do better on their exam this year. And so I pushed through. Many times I had to pause and stuff. But guess what? I made it. And I know you are going to be happy that you got this help. So with all that being said, guys, let's start our revision session. We start off with simplifying expressions. So here we're asked to simplify a plus a plus a. Guys, the answer is simply 3a. So just think about this as 1 apple plus 1 apple plus 1 apple. There are 3 altogether. Do not mix this up with multiplication. Very important. For the next question, we're asked to simplify 3c minus 10d minus c plus 4d. A good practice is to collect the like terms. So 3c minus c, that's important. I'm going to put the positive d term first. So 4d minus 10d. Now we can see clearly the signs and make sure that we observe them as well. So 3c take away c, or 1c, is equal to 2c. And then we are subtracting a large number from a small for the d terms. So 4 take away 10 is minus 6, and the variable is d. Make sure that you pay keen attention to that. So similar question, 7y plus 2w minus 3y plus 2w. Again, I'm going to collect them in their pairs. So 7y, I've got a minus 3y plus 2w and another plus 2w. Signs important. So 7 take away 3, that's 4, and the variable is y. 2 plus 2 is 4, and the variable is w. Beautiful. So we go on to the next term, which is very, very important. 2x squared plus 3x minus 1 minus x squared plus 2x minus 5. Very important to note that x squared and x are not like term, so we have to put the x squares together and the x together separately. So we go for 2x squared and minus x squared, followed by positive 3x, followed by positive 2. We got minus 1 and minus 5. Now we can simplify them. So 2x squared, take away 1x squared, will leave us with just 1x squared, which we just write as x squared, plus 3 plus 2 is 5, so that's 5 in terms of x. And then minus 1, minus 5, I owe 1, I owe 5, I owe 6 all together. If you have to use your number line to make sure you get these correct, make sure you do, that you do not give away easy marks. Brilliant. So we continue. Further simplifying expressions with some multiplication, subtraction, division, and so on. So here, we're asked to simplify A times B times C. Remember, we're just putting them all together in multiplication. So the answer then is just ABC. Do you know your ABC? I hope you do. So next question says, simplify 5p, take away 2p. Again, variables the same, we're just subtracting. This is simply 3p. Now, next question, we are dividing 6h by 3. So we're dividing 6 by 3, which is 2. Don't forget your h. So we're just halving 6h, which is 2h. Then we go for 6f, take away f. So remember, a single f is the same as minus 1f. So 6f minus 1f is just 5f. And again, for these ones, we are collecting the like terms. So 7x plus 3x, or 7x squared plus 3x squared, and positive 6x minus 3x. Notice I put my positive first always. That helps me to see if I'm taking a large from a small, or is it okay to just go ahead and subtract 6 from 3? In this case, yes, it is. So final answer, 7x squared plus 3x squared is 10x squared. And then 6x minus 3x is positive 3x. Make sure that you pay attention to your signs. Now we go for another multiplication, which is A times B times 3. Remember, coefficient comes first. So this is just simply going to be 3AB. Check that off. Now, this is the one that you confuse sometimes with your addition versus your multiplication. So we're doing y times y times y. Remember, multiplication is where we end up with an indices or power, or we could also call it an exponent. So now this is y to the power of 3. If it was y plus y plus y, it would be 3y altogether. Now here we are doing 10d divided by d. So these cancel out each other. We're just left with a numerical value of 10. Next question is a division. 9k squared divided by 3k. We're dividing coefficients together. So 9 divided by 3 is 3. And k squared divided by k. So basically, we could look at this as canceling out 1k from both sides, or numerator and denominator. Therefore, we'll be left with 3k. Lots of mistakes can be made there. For simple question, guys, we cannot afford to lose the simple marks at all, because when we get to more challenging questions, we're going to be in trouble. Okay, so make sure that you consistently check. Now we go for matching up algebraic terms. So link the algebra to the correct description. One has been done for you. So the first one is p equal to 3x plus 4y. That one was done for you. It is a formula. Now for the next one, 3x plus 6. That 3 equal sign here means identity, means that what we have on one side is equal to what's on the other side. So to see this clearly, 3x plus 6. And if we expand the bracket here, on the other side, we can see 3 times x is 3x, and 3 times by 2 is 6. So both sides are identical. So therefore, this one here, it is and I've pre-drawn the lines in to make it neat. So that one is an identity. Beautiful. Next one is 3x plus 2 equal 14. Equal 14, that suggests equation. So once there is an equal sign, then it will be an equation for that one. Now, the difference between the expression and the expression does not have an equal sign, which makes the next one an expression. Beautiful. Now, by now, we have done lots of work around inequalities. We know that once we have less than sign, less than or equal to, greater than or equal to, we are talking about inequalities. 3 marks. So, the difference between an equation and an inequation or an inequality, the equation has just one answer. For example, 2x equal 10, the only option for an answer is 5, since 2 times 5 is 10. But if I say x is greater than 6, every number above 6 is a part of the solution. So 7, 8, 9, 10 to infinity, okay? One has a range of values, the other has just one solution. Brilliant. So now we go on to forming algebraic expressions. So John thinks of a number x. He adds 5 to his number. Write an expression in terms of x. So lots of people mix up simple question like these, guys. He had x first, and he is then going to be adding 5 to that. So the expression will be x plus 5. If you write 5 plus x, it's wrong, because that would mean that you started with 5, then add x on. But in this question, he started with x and is going to add the 5 to that. So look for your starting point. Next question. Sarah thinks of a number y. She subtracts 10 from the number. Write an expression in terms of y. So we start with y. We are subtracting 10. So y minus 10. Very simple there. Mark thinks of a number. He multiplies it by 2, then adds 10. Write an expression to show this. So this is where you got to be careful. So it got a number, doesn't matter what letter you use for that. So I'm just going to use x, then multiply it by 2. So that bit alone is 2x. After he's multiplied it by 2, he's then adding 10 to that. So the expression this time will be 2x add 10. Beautiful. Now, final one for forming expressions. Sharon thinks of a number, add 2 to the number, then multiplies the result by 6. Write an expression to show this. Again, be careful. So thinks of the number. This time, let the number be y. What is the first thing that was done to that number? 2 was added. So now we are ending up with y plus 2. Then all of this result is multiplied by 6. So the y and also the 2 has to be multiplied by 6. I'm just going to put the 6 on the outside of the bracket to show that. I'm then going to expand the bracket. So 6 times y is 6y. And 6 times 2 is 12. So the expression then is 6y plus 12. No harm would be done if we kept it in bracket, but we can expand it to show a more simplified answer. Absolutely brilliant. Okay, so now we go to expanding brackets. I'm going to start with single brackets first, and then I'm going to go to double brackets. So I've done all of the expansions, single bracket, double bracket, triple bracket, in the Year 9 playlist. You can find that link here. I will put the link in the description, but you can see what the video looks like. Just go to the Year 9 playlist and you'll see all the lessons I've done, most of which I've started off with what you should have started off with on your scheme of work from September. So lots of things there for you to watch as well. So we're asked here to expand and simplify the following. 3 bracket x plus 5, so 3 times x is 3x. 3 times 5 is 15. Nice, simple, easy does it every time. Next we go for 2p bracket p minus 7. So 2p times p is 2p squared. 2p times by minus 7 is minus 14p. And there we have it. Now, 7 bracket a minus 2. Pay attention to your negative numbers. 7 times a is 7a. 7 times minus 2 is minus 14. We then go for minus 3q, bracket 2q plus 5. So again, remember, negative. Multiplying the coefficients, negative 3 times by 2 is negative 6. Q times q is q squared. And then minus 3q times by 5, so multiplying by a negative here, will be minus 15q. Don't forget your letter at all. Okay, so 4 nice expansions there. We carry on. Now we are asked to expand x plus 9 to the power of 2. A lot of people forget that square means you're multiplying what is in the bracket by itself. Indication, I need to write 2 of the same brackets and then expand it. So I will have x plus 9 and another x plus 9. So x times x gives us x squared. X times by 9 gives us 9x. 9 times x also gives us 9x, and then 9 times by 9 is 81. Timetable is very important here, guys. So this is a quadratic. When we expand 2 double brackets in the same variable, we will get a quadratic. How do I know? The highest power will be a square. So x squared, we can simplify the middle since we are collecting like terms. You'll see why I did collection of like terms before expansions. So 9 plus 9 is 18, and in terms of x plus 81. Spot on. Beautiful. Now be careful with your expansion that includes a negative. So x minus 4 is being multiplied by x, add 2. So x times x again gives us x squared. X times by positive 2, positive 2x. Notice how I say it. I want to hear it. Minus 4 times by x is minus 4x. And minus 4 times by positive 2 is minus 8. So be careful of your simplification for the b term, which is the middle part where we have x terms. So x squared will always be x squared. Now I'm doing 2 minus 4. I'm going to get a negative 2x because I'm taking a large number from a small number. Lots of people expand and then collecting like terms. They lose the last mark. That's not you. And then at the end, minus 8. Beautiful. So now we go for expanding, but this time we have 2 negatives in the brackets. Same principle applies. Say it so you can hear it back to yourself to avoid simple mistakes. So x times x gives me x squared. X times minus 1 give me minus x. Minus 7 times x is minus 7x, and negative times negative give me a positive. So 7 times 1 is 7. Simplify the b term. Minus, so this is minus 1x minus 7x. I owe 1, I owe 7, I owe 8 altogether. Think about as owing plus 7. That will help you to think of it in the right order. Now we are going to expand. Notice this one, 2x plus 3. So now there is a coefficient before x. And then x plus 4. So we still apply the principle. 2x times x is 2x squared. 2x times by 4 is 8x. 3 times x is 3x. And 3 times by 4 is 12. Again, the x term will remain the same. Middle term will add 8 plus 3, 11 in x, and positive 12. Brilliant. Yes, you are becoming brilliant by numbers. Fantastic. So now we go to perimeter and area using algebraic expressions. So here, shown is a pentagon. That means 5-side penta. Find an expression in terms of x and y for the perimeter. Lots of people mix up perimeter and area. Remember, the prefix peri means around and meter means to measure. So I am measuring the distance around the shape. So the perimeter then will be equal to y plus x plus x plus 2x. So again, collecting my like terms, I get 1y plus 1y, 2y, 1x plus 1x, 2x plus 2x, that's 4x. So my answer will be 2y plus 4x. I love to write in alphabetic order, so I'm going to put my x term first. You would still get it correct, even if you didn't do that at all. Okay, so 4x plus 2y. Now, the rectangle is shown. We've got two dimensions, x plus 9, x minus 1. The length of the rectangle is x plus 9 and the width is x minus 1. Calculate the area. So again, guys, we know that the area of a rectangle is equal to the length multiplied by the width. Therefore, I'm doing x plus 9 multiplied by x minus 1. So this is another way my double brackets could be presented to me. And when I know that, this is light work. So x times x is x squared. X times by minus 1 is minus x. 9 times x is positive 9x. And positive 9 times negative 1 is negative 9. So again, I will be simplifying my b term, which is the middle. So again, all 1x, but I have 9x, so 9 take away 1 is positive 8. And in x, and then minus 9. Beautiful. Okay, so we go on to another question here. Still on perimeter and area, but this time we're told that the rectangle ABCD is shown below. We see dimension, a part of the AB is x and a part of it is 7. A part of AD is x and a part of it is 2. We're told that the area of the rectangle ABCD is 230. And we're asked to show that x squared plus 9x is equal to 216. So first train of thought is that I'm finding the area. So I know I'm going to do the length times by the width. So let's get the length here. If one part is x and the other is 7, all of it from A to B will be x add 7. And all of it from A to D will be x add 2. So we're told that the area is equal to 230. It means that when I multiply x add 7 and x add 2, the answer should be 230. So now I'm going to expand my bracket and make it equal to 230. So we go x times x is x squared. X times by 2 is 2x. 7 times x is 7x. And 7 times by 2 is 14. We then need to simplify the middle term, which is our b term of the quadratic. So x squared plus 9x plus 14 is equal to 230. But remember, they say show that it's equal to x squared plus 9x is equal to 216. So therefore, I need to have just x squared and 9x on this side. So I got to minus that 14. So therefore, x squared plus 9x is equal to, let's just subtract 230, take away 14, take 1 from here. So this will leave me with 6. This will leave me 2, take away 1 is 1, and I still got 2 here. So then I have shown that x squared plus 9x is equal to 216. The show questions are amazing because you would know if you're wrong if when you work it out, you do not get what they've got here. Beautiful. So guys, we go on to sequences. Which of these is a geometric sequence? So my first thought is the key vocabulary here. What is a geometric progression? Now, in a geometric progression, each number is multiplied or divided by the same number. Okay? So I'm looking for which one. I'm going up, multiplying by the same number. So here I can see that for this one, I'm just going up by adding 2. Not multiplication, not geometric elimination. I go for the next one. I notice that these ones, 1, 4, 9, 16, 25, what numbers are those, guys? I hope you said square numbers. So this one is not the geometric at all. So for the next one, I've got 1, 3, 6, 10, 15. These ones are my triangular number. So if you notice from here, we're going up by 2, then by 3, then by 4, then by 5. That's a triangular number. So let's check the next one. How do I get from 1 to 3? I multiply by 3. 3 times 3 as well is 9. 9 times 3 is 27, and so on. So this one is my geometric progression, multiplying or dividing by the same number. Beautiful. The first four terms of a sequence are minus 10, minus 8, minus 6, and minus 4. Circle the expression for the nth term of the sequence. So what you would do first, you work it out and then look for which option is the answer. If you're correct, you should see it there. So remember, to find the nth term of a sequence, we need to, first of all, find the difference or what we're going up by. So how do I get from minus 10 to minus 8? I add positive 2. So to get from minus 8 to minus 6, I'm adding 2 as well. And also from minus 6 to minus 4, adding 2 as well. So then it's going to be 2n, where n is the position 1, position 2, position 3, position 4. Now, in order for me to find out what should be added here, I can either go find the 0 term. What would have come before the first term, which would be my 0 term? So to find that out, I need to simply do minus 10 minus 2. So minus 10 minus 2 is minus 12. So the answer is this one. Beautiful. So to find the last part of your nth term, you simply need to find the 0 term. What would be the one before the first one? And that would be my answer. Beautiful. Now I can do a quick check to see if I'm correct, because when n is 1, then 2 times 1, take away 12, should give me minus 10. So 2 times 1 is 2. 2 take away 12 is minus 10. So yes, I know I have selected the right answer. Absolutely fantastico. Okay, sequences again. Here are the first 5 terms of that linear sequence. 9, 15, 21, 27, 33. Work out the nth term. So guys, the multiple choice question got us to do the work for that one. So now you should at least be able to pause the video and find the nth term of this one. So remember, first thing we need to do is to find the difference between them. So first difference here, we can see to get from 9 to 15, we could do 15 take away 9, which is 6. We're adding 6. 15 plus 6, 21. 21 plus 6. So it's going to be 6 times by n, which is 6n. So let's find the 0 term to get the answer for the nth part here. So the 0 term, we need to do 9 take away 6. 9 take away 6 is 3. So positive 3. So the nth term then is 6n add 3. And remember, I can check. 6 times 1 is 6 for the first term, plus 3 gets me 9. 6 times 2 for the second term. If you got a second term, 6 times 2 is 12 plus 3, 15. Spot on. Absolutely fantastic. Okay, so we're going to do another sequences that involve patterns this time. So the sequence of patterns is made using sticks. Got pattern 1, pattern 2, pattern 3 here. We're asked to complete the table for pattern 4 and pattern 5. So again, number of 6, we can see we got 5 to 9. That's going up by plussing 4. 9 to 13 by 4 as well. So now I need to do 13 plus 4, which gets me 17. So pattern 4 has 17. Next, I'm doing 17 add 4, and 17 add 4 is 21. So pattern 5 would be 21. Now we are asked to work out the nth term of the sequence. So we just did that. So pause again, do it for yourself. So we know that we're going up by 4. So that is 4n. Let's find the 0 term now. So 5 take away 4 gets me the one before. You heard that, guys? So therefore, 5 take away 4 is 1. So the nth term is 4n plus 1. Check. When n is 1, 4 times 1 is 4 plus 1 gets me the first term. Correct for my nth term. Now, question part C says, which pattern is made using 53 sticks? Now, when that question is asked, it means that we need to find the value of n when the equation, so we're going to make an equation with the nth term. So to answer part C, when the nth term, which is 4n plus 1, is equal to 53, we need to work out what n is, and that would be the position of that pattern that is having 53 sticks. So we know to solve equations, subtract 1, subtract 1. So we've got then 4n is equal to 52. 53 take away 1. So now I'm going to divide to find n, divide by 4. So let's do that here. So 52 divided by 4. 4 into 5 goes once, remainder 1. 4 into 12 goes 3 times, so 13. So which pattern? The 13th pattern is my answer. Absolutely brilliant. Guys, look how far you've come. Make sure you like the video. Make sure you hype the video. Send it up in the YouTube algorithm. So guys, we're going to look at this question that helps us to revise all the different types of sequences. So it doesn't matter which one you get on your paper, you will know how to handle it. So we're asked here to match each sequence to the description, and one has been done for you. Okay, so the one that is done for you is called the Fibonacci sequence. Remember, in a Fibonacci sequence, the two preceding terms are added together to give you the term that follows. So let's just have a look at it. So 1 plus 1 gives us 2, 1 plus 2 gives us 3, 3 plus 2 gives us 5, and so on. So whenever that happens, it is the Fibonacci sequence. So that one was done for you. Now we look at the arithmetic progression. So remember, when we're talking about the arithmetic progression, we mean that we are adding or subtracting by the same number. Remember that? So arithmetic, we are either adding or subtracting by the same number. So now we're going to look in the sequences here and see which one is adding or subtracting by the same number. So here we look at this one. We can see we add 1, but that wouldn't work for the next one. It's not the same number. So here, 1, 2, 3, 4, 5, 6. Clearly, that one is our arithmetic progression. Okay, I've put pre-lines in so that it's neat. Not sure what they are, but let's just write A here and then I will match them after. So that's the arithmetic one. So for the next one, let's observe what is going on and then see which is it. So how do I get from 1 to 2, then to 4? So 1 times 2 is 2, 2 times 2, 4, 4 times 2, 8. And we've done this already further up. So this one is our geometric sequence. So arithmetic, let's match that. Geometric is right across from its name. Now we also have revised this one earlier on. So 1, well, let's look. We are adding 2, then adding 3, then adding 4, then adding 5, then adding 6. Hope you've said it. It is the triangular sequence. So remember, we are adding the other counting number that comes in line in consecutive order for the triangular sequence, starting with 1. So that is also across from its name. Now, I hope everyone now knows our square number. 1 times 1 is 1, 2 times 2 is 4, 4 is the next square number, 3 times 3 is 9, 9 is the next square number. Catch that rhythm. So we know the next one, 1, 4, 9, 16, 25, and 36 is our square number pattern. And then our cube numbers, we are multiplying each number by itself 3 times. So 1 times 1 times 1 is 1, 2 times 2 times 2 is 8, so 3 times 3 times 3 is 27. So the last one then is our cube numbers. Make sure you know your different types of sequences. Beautiful, for 4 marks. Moving along, we're asked now to calculate each sequence, if each sequence is a linear, a quadratic, or neither. And then the challenge is, can you say what they are if it's neither? So let's look what's going on in the first one. First one, we are going up from 6 to 10 by 4, from 14 to 18 by 4. So we can see going up by adding the same number. Clearly, this one is a linear sequence. So the linear sequence is basically the arithmetic sequence. So linear. Next one, let's see how we get. So 5 plus 5 make 10, 5 plus 10 make 15, 15 plus 10 make 29. What is it? We just talked about it, so it is Fibonacci. So we would say neither, and they've asked us to say what it is. In bracket, we put Fibonacci. Beautiful. The next one, let's see what we've got here. So difference here is, so we got 1, 4, 7. So we're going up by 3. Going up by 3, guys, my mouse is messing with me. Going up by 3, going up from 10 by 3 by 3. So again, this one is linear. Then we go for the next one from 6 to 10, that's 4. Then we are going from 10 to 16, that's 6. Then from 16 to 24, that's 8. Then, so you can see all, then 24 to 34. So all the differences are different. So remember, in a quadratic sequence, when our first differences are not the same, that's how we know this is quadratic. So then we have to go for a second difference. So 4 to 6 is 2. Then this one is also from 6 to 8, 2. So now our second differences are the same. So we had 2 steps before we could get to the second difference. So this one is a quadratic sequence, which we would see represented, for example, as n squared. So it must have a square if it's a quadratic sequence, okay? So if they give you a term with a square in it, we know it's a quadratic sequence. Beautiful. So let's go for the next one. Let's see what's going on from 2 to 6, 6 to 18. So 2 times by 3 is 6. 6 times by 3 is 18. 18 times by 3. So we're multiplying by the same number. I hope you remembered it. It is geometric. So we would say neither, because that wasn't an option. And then we would say it is geometric. Okay. For the next one, let's see how are we getting from 3 to 1. So from 3 to 1, I am subtracting 2. From 1 to minus 1, I'm also subtracting 2. From minus 1 to minus 3, I'm also subtracting 2. So minus 1 minus 2 is minus 3. Minus 3 minus 2 is minus 5. So again, by the same number. So also, this one is linear. And then for the next one, I've got 3, 3. So let's see if we got a common difference here. So from 3 to 3, that's 0. From 3 to 5, that would be 2. Then from 5 to 9, that's 4. And then from 9 to 15, that's 6. So again, the differences are not the same. But let's see if they are the same when we go again. So from 0 to 2, that's 2. 2 to 4, that's 2. So yes, our second differences are the same. So again, this one is quadratic. Absolutely brilliant. So this one says, a biased dice is thrown. There are the probabilities of each. Here are the probabilities of each score. So we got 1, 2, 3, 4, 5, 6, and their probabilities given. We're told that the die is thrown. I got to get back my red pen. I love my red pen. So the dice is thrown 200 times. Work out the expected number of times we will score. The score will be odd. Okay, so we need to get all the odd numbers. Odd numbers, 1, 2, 3. So remember, expectation is equal to the relative frequency or the probability. So relative frequency multiplied by the number of trials. So what we need to do is to add up the relative frequency, which is the same as our probability here, to see what all of the odd numbers add to. So we're adding 0.25 plus 0.15 plus 0.3. Just going to put that in my calculator quickly, get an answer, which will be my total relative frequency. So let's put that in our calculator. So I've got 0.25 plus 0.15 plus 0.3. That's 0.7. So it's my relative frequency, 0.7, times by the number of trials, which is the 200 there. So 0.7 times by 200 is 140 times we would be expecting to get an odd number. Brilliant. So now we are moving to two-way tables again. I have done this lesson here on two-way tables. Make sure you find that and watch it as well so you can see more challenging questions. So a cinema records some information about visitors they have 1 week. So we've got day, adults, children, so 2 categories, and 2 days, Saturday and Sunday. We got the total column, and so then we are asked to fill in all the missing values. So clearly we have to start filling in from places that just one variable is missing. So we can start off by finding the adults for Saturday. So adults, Saturday would be equal to, so I'm finding this, I'm doing the total, which is 212, take away 115. I'm just doing a column method straight away. If you got your calculator, you can just plug that in. Okay, so we go for, we have to take 1 from here. So 12 take away 5 is 7. And then we have to take 1 from here again. So 10 take away 9, take away 1, sorry, is 9. So this one is 97. Fill that in our table, tick that off. Now we can find the Sunday for adults since we know the total. So adults, Sunday, so I'll just write Sunday, keep it in that column. It will be 143 take away 97. So again, we have to take 1 from this column. So 7 take away from 13, that's 6. And then we could just do 9 from 13 here, which is just 4. So for that one, it is going to be 46. Beautiful. Take that off. Then I can find the total for Sunday here. I can do, so Sunday total. And that's going to be 360 take away 212. So take 1 from here, leaving 5. So 10 take away 2, that's 8. 5 take away 1, that's 4. 3 take away 2, that's 1. So this is 148. Take that off. Gaps closing. I can now work out either of these two because I have 2 totals and a single. So let us find out the children for Sunday. So Sunday, children. Okay, so that will be equal to 148, and we're subtracting 46 from that. Nice and easy one there. So 8 take away 6 is 2. 4 take away 4, 0, so 102. So we put that in. This one is nice and easy now because for the last one, I can just do 102 plus 115, which gets me 7. 0 plus 1, 1, and 1 plus 1, 2. So that's 217. Brilliant. So 3 marks to do that. See what I did? I did my working out. Make sure that you do that as well. Absolutely brilliant. So now we're going to move on to another probability question where, so this question seemed to have been replicated, guys. So we did it already. So I'm just going to skip through that one. If you want, you can practice it again on your own. For some reason, I got it twice. So here, for this one, listing outcomes, the probability of heads when a biased coin is thrown. So heads is 0.6. The coin is thrown 500 times. circle the expected number of tails. Don't be confused. They gave us heads, but they asked us for the tails. So tails then, the probability for tails, we got option to choose from as well. For tails then, if it's 0.6 for the heads, then 1 probability adds to 1. Take away 0.6 is 0.4. So then I need to do 0.4 times by, so relative frequency times number of trials. So we're doing 0.4 times 500, which is the same as 4/10 of 500. So I'm just going to use my calculator quickly. 0.4 times 500 gets me 200. Guys, my hay fever is giving me a hard time, but persistence, resilience equals success. That's what I want to communicate to you here. So the answer is 200. Moving on to listing outcomes, which you can find a further full lesson on that here. Listing outcome combines with the sample space diagram there. So Callum is making pizza. He can choose from 3 different toppings. He's got ham, sweet corn, onion, mushroom. So he can choose 3 from those. List all the possible options for the 3 toppings. The first one has been done for you. So the first thing I would say, write them out. So you can get H for a ham, a sweet corn, a O, and a M. So the first one was done for you. I'm still going to do it and then just tick it off just to keep your line of thought. So he could get a ham, a sweet corn, and onion. Tick that one because it was already done. Let's stay with the ham, sweet corn. He could have a ham, sweet corn, and mushrooms. Okay, so ham, sweet corn, onion, or ham, sweet corn, and mushrooms. Then he could get a sweet corn, onion, and mushrooms. So let's see if there's any other option left. So there were 4 options. One was done for us. So the next one is just S, H, S, M, and then S, O, M. Okay, making sure that I got them all. So then let's just check. S, H, S, O, H, S, M. We could have H, O, M as well. So H, O, M is the last one. Okay. All right, so check those off. Beautiful. All right, moving along. Sorry, guys, but under the weather, man. All right, so we got on to Venn diagrams. So you can watch this video here if you need more practice on Venn diagrams, because I haven't done a lot here since I know that one's there as well. So here is a Venn diagram. So write down the numbers that are in the set. So in the Venn diagram, the E here means the universal set, which has all the possibilities. So I've got C and D. We're asked to write down. So we're just looking on the Venn diagram and writing down the values that we are asked for. So we are asked to write down the numbers that are in the set D. Common misconception here is to think that where 6 is the only D. Remember, D is all of the circle here. So it's 5, 6, and 9 are the numbers in that part. So the next bit is C union D, which means everything in C and D together. So it will be, let's get them in numerical order. That will be 1, 4, 5, 6, and 9 is what's in both circles. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Quick check. Then I'm asked to do C complement. So this little dash means what is not in the circle C at all. So this is the circle C here. What is not in that is 6, 7, and 11. So 6, 7, and 11. Absolutely brilliant. Okay, so we move on to another Venn diagram, but this time it's going to be a little bit different. Some addition has to be done. So at a wedding, the guests may have ice cream, custard with their dessert. The Venn diagram shows information about the choices the guests made. So we can see ice cream here, custard here, and who didn't choose either of those is outside. How many guests had custard? So remember, custard is the entire circle. So that is 9 plus 34. So 9 plus 34, that's going to be equal to 43. So guys, make sure if it's non-calculated, this comes on. Make sure that you set it up like this and not guess it in your head. So 9 plus 4, 13. And then 4 plus 3 plus 4. 3 plus 1 is 4. So that's 43. Tick that off. How many guests had ice cream and custard? So we are looking for the middle of the Venn diagram, which is 9. That's here. Okay, tick that off. How many guests went to the wedding? So we need to add either the people who didn't take ice cream or custard at all. So we're adding everything up. So that is 51 plus 9 plus 34 plus 14. All right, so I'm just going to put that in my calculator. So 51 plus 9 plus 34 plus 13, that is 107. All right, so if this is non-calculator, just break it apart. We can see 51 plus 9, 60, then 60 plus 34 is 94, then plus 13, 107. So we continue with Pythagoras' theorem. So before I forget, guys, I have done a full lesson on Pythagoras theorem, also Pythagoras theorem and coordinates. It's 2 separate lessons, again, in your Year 9 playlist. This video here, link will be in the description as well. So we're asked to label each part of the right angle triangle shown below. So by now, all of us should know that the part that's facing the right angle, which is the longest side, is the hypotenuse. So clearly, first box on top is the hypotenuse. So this symbol here represents an unknown angle. It's a Greek symbol called theta, and that represents an unknown angle. Next, facing our angle will always be, or we could say opposite to our angle will always be the opposite side. And then the side on which the angle sits, which theta sits, here in this one, is our adjacent side. So what I always say is that it's easy to get the hypotenuse and the opposite. Those are clear. Adjacent is what most students forget. So label your hypotenuse, your opposite first, and then the other side has to be the adjacent. Beautiful. So now we go for some calculations. We're going to need our calculator, so let me prepare myself. So we're asked to find the length of the side marked X. So I have this triangle here, clearly is a compound shape. So I want to find X. We know that if we're doing Pythagoras theorem and I want to find an unknown side, first of all, we have to be able to know 2 sides on this triangle. So if I look on the triangle onto which X is, I recognize that I only know the side 7, but I don't know the hypotenuse, which is the longest side. Not the hypotenuse. We got the hypotenuse, just don't know the other side, which happens to be one of the shorter sides, which I'm going to call Y for now. But I could use the second triangle using 7 and 9, which is the hypotenuse. So Y would be the hypotenuse on that shape. So what I'm going to do, and you should do it too, is to separate the triangles. So the Y I labeled here, 9 here, 7 here. So I'm going to use the first triangle, let's call that triangle 1 here, to find what Y is and put it onto the other shape. Then I would know 2 sides. I could use 7 and that answer to find X. So let's go. Pythagoras theorem tells us that a squared plus b squared is equal to c squared. So we need to check. We only are adding if we are finding the longest side. In this triangle, we are finding the hypotenuse. So therefore, substituting 7 squared plus 9 squared equal to, let's just call it y squared since we're trying to find the y that we labeled. So 7 times 7 is 49, because this could be non-calculator as well, but they'd give you values that balances off where you can find the square root of those numbers. 9 times 9 is 81, and that's equal to y squared. So 49, let me just use my calculator here, 49 plus 81 is equal to 130. We know that's y squared. We need y, so now we need to square root both sides. So y equal to, I'm going to leave my answer as square root of 130, and that's because I'm going to use it again. So to keep it accurate, it's best to leave it in its exact form. So we put that on the diagram now. Now I can find x. I'm just going to draw that triangle out as well. So I've got the root 130 here and 7 here and x. So again, I'm finding the hypotenuse. So a squared plus b squared equals c squared. So 7 squared plus root 130 squared equal to x squared. So 7 times 7 is 49. Now guys, whenever we square a square root, we remove the root, leaving us with just the number. See why it was easy to do? So then that's equal to x squared. So that simplifies to 130. 130 plus 149, remember if it's a calculator paper, use your calculator even though this one is simple. This is 179 and that's equal to x squared. So again, square root, square root. So x will be equal to, let's see, square root of 179 is equal to one decimal place, 13.4 centimeters. Now guys, remember, whenever you are going to round, if you're going to round to 1 decimal place, check the digit after. If it's 5 or more, round up. If it's less, you round down, or just that means keeping the number the same. Beautiful. So now we go to Pythagoras theorem and coordinates, which I mentioned that there's a video on that as well. So we're asked here to calculate the length of the line joining A and B. So the length of AB. Now, if you notice, we could complete a triangle to make it a right angle triangle as well on the coordinate grid. So to get our lengths, we can just count the squares. So look, we're going up in ones, but if we weren't, you would count the numbers instead. So 1, 2, 3 squares and 1, 2, 3, 4. So again, we're finding AB, longest side. So AB, to find that, we're going to do a squared plus b squared equal to c squared. So 3 squared plus 4 squared is equal to c squared, which is actually our AB. 3 times 3 is 9. 4 times 4 is 16. So this one could actually be on the non-calculator paper because it's just all your square numbers. 9 plus 16, 25 equals c squared. Square root, so c is equal to 5. So 3, 4, 5 are the lengths of the side. This is called a Pythagorean triple. Remember that. If we double them, 3 times 2, 6, 4 2's 8, 5 2's 10. Also a Pythagorean triple because these come in order, 3, 4, and 5 consecutive, and then 6, 8, and 10 also consecutive even numbers. Pythagorean triple. Fantastic. We move on to this question that asks us to work out if each triangle below is right angled or not. The triangles are not drawn accurately. So remember guys, if a triangle is right angled, then a squared plus b squared should be equal to c squared. So we're going to square a and b and add them together. And if we get the same thing when we square c, then it's a right angle triangle. If we do not, then it's not. So let's go. So we're going to square the two short sides, which is 40. So 40 squared and 8 squared should be equal to, so we're testing if it's equal to 41 squared. 40 squared is 1,600 plus 80 8 squared, sorry, is equal to, or you could just put it all in your calculator, because definitely this one is going to be on the calculator. So that's 64 and equal to, let me just do 41 times 41. That's equal to 1681. So adding these together, 1600 plus that, I get 1664. So it is not equal to 168. So now you're going to conclude not right angled. Beautiful. So we go for the next one. Same principle apply. 52 squared plus 39 squared should be equal to 65 squared. Let's get it all out. So 52 squared, that's equal to 2704 plus 39 squared, that's equal to 1521. Added together, that is 4225. Beautiful. Then 65 squared now. 65 squared, that is also 4225. See that, guys? So yes, right angled. Absolutely brilliant. So that's how we test if a triangle is right angled or not. Now we are going on to, guys, this label says Pythagoras theorem, but we actually are going on to trigonometry now. Okay, so forgot to change my labels. So how do I know I have a trigonometry is when I only have one side and an angle. Pythagoras, two sides. Okay, so trigonometry is what we're going to use. So the three trig ratios to remind you are SOHCAHTOA, so sine, cosine, so ka, and TOA. So S is for the sine ratio. On your calculator, students always say sin. So sine, and C is for cosine, and T is for tangent. Again, guys, I've got a thorough video on trigonometry. There is the link. I'll link that in the description as well. This video here, lots of you need more practice on this. I just know it. So now we're asked to find the missing sides of these triangles. So remember, step one is to label the sides. We always stand at the angle when we are going to label. Opposite to the angle is the opposite side. And then the hypotenuse is the longest side. Clearly, we don't have anything to do with that because it's not labeled at all. So the other side has to be the adjacent. Do not label the side that has nothing on it. It will confuse you. Only label the one you know and the one you want to find as well. So OA, the ratio that has OA is tan. So we are going to do tan. So tan 35, so that's the angle. So tan is equal to the opposite, which is 10, over the the adjacent, which is x. So again, OA. So when you get in your exam, as they say, begin, write SOHCAHTOA down. Okay? So OA, so opposite over adjacent. So now we need to get our calculator. So the letter here is at the denominator. That means we will have to divide. So x would be equal to 10 divided by tan 35. Put that in my calculator. 10 divided by tan 35. I'm going to give my answer to two decimal places, guys. So that is 14.28 centimeters. Check that off. On to the next question. Go to the angle, and facing the angle is the opposite side. Facing the right angle is the hypotenuse. So OH, the ratio with both O and H is sine. So sine 4e is equal to, again, opposite comes first. So that's 8 on the numerator. And the hypotenuse is x. Again, letter on the denominator, we are dividing. So x is equal to 8 divided by sine 40. Calculator. 8 divided by sine 40. I'm going to give my answer to two decimal places again. So x is equal to 12.45 centimeters. to the next question. So I've done one where we're using all three ratios just for you to get that practice. So going here, I can see from 70, start at the angle. There is no opposite. Opposite ruled out. So hypotenuse is the longest side. If opposite is not there, the other side has to be the adjacent. So AH, I'm using cos. So cos 70 is equal to the adjacent side, which is x, over the hypotenuse, which is 6. Letter on the numerator, I'm multiplying. So basically, how I know I'm multiplying, when I can make a straight line between the numbers and not with the letter, okay? So I now need to do x equal to cos 70, make sure you put that in bracket, equal to, so cos 70 times by 6. So let's go for calculator. So cos 70, close back your bracket, times by 6 is equal to 2, sorry, my mouse glitches, 2.05 centimeters. I know I'm correct because this number is smaller than the hypotenuse, and the hypotenuse is the longest side. Brilliant. So now, guys, we're going to find some missing angles this time, and that will conclude our trigonometry. So again, we're asked to find the missing angles in the right angle triangle below. Again, title here is wrong, but that's the least of our worries. We've got X, we stand at the angle. So facing that is the opposite, and we've got the adjacent side since this is the hypotenuse. So again, TOA. I'm using OA, so that's tan. So tan X, since I don't know the angle, is equal to opposite, which is 3, divided by adjacent, which is 6. So guys, when we're finding an unknown angle, we have to use the inverse function on the calculator. Make sure you watch the trigonometry video. I've also taught you how to use it. So therefore, X would be equal to, we have to do the inverse of tan. So you would press shift on your calculator. So that's going to be tan inverse. When you press it, you're going to press shift, then tan. You're going to see the -1 comes up, and then it's going to be 3 divided by 6. Put that in my calculator. So I'm going to press shift tan 3 divided by 6. I get 26.6 degrees. Remember, it's an angle this time. Check that off. On to the next question. Remember, I'm standing at my angle. I've got in this question, facing the angle is O, facing the right angle, longest side is H. So ratio OH. O and H is sine. So sine X again is equal to the opposite, which is 4, over the hypotenuse, which is 15. Remember, inverse for angles. So X would be equal to sine inverse of 4/15. So calculator, shift sine, I see my inverse comes up, 14 divided by 15, I get 15.5 degrees to 1 decimal place. So again, we've used tan, sine, now we're going for cos. So again, no opposite given, opposite is ruled out. Hypotenuse, longest side, the other side has to be adjacent. So that's AH cos. So cos X is equal to the adjacent, which is 8 over hypotenuse, which is 10. So guys, once you write this down, the first letter that comes first after the C and the S and the T should go on the numerator on the top. So then X will be cos inverse of 8 divided by 10. So we go for it. Shift, press cos, then 8 divided by 10 to 1 decimal place is 36.9 degrees. Finished with our 3 trig ratios. Look at you. I'm so proud of you guys. Now we go on to congruence. Nice and easy, does it every time. So we know the conditions of congruence. They are all given here. So we're working on this one as multiple choice for these congruence, just to remind you. So circle the reason why these triangles are congruent. So most of you always get this one. Side, side, side. So SSS. So we got a side here. Sorry, this is not SSS. This is a side angle and a side. So let's check that the sides are the same. So we got a 9 here, we got a 9 here, we got a 5 here on this one, a 5 here, and also 20. And the angle has to be in between the two sides for it to be side, side, side. So let's go side, angle, side. Side, angle, side. So this one is SAS. Let's get our SAS on. Yes, guys. So first one is SAS. So now we go for the next one. So be careful when you see a right angle. Don't just run and think it's RHS. Reason the question because you could be wrong. So why this is congruent. So we notice we got an angle, a side, and an angle. Now, why this is not RHS is because there is no hypotenuse given. Remember, for us to use RHS, we've got to have a the hypotenuse given and the right angle and another side. So this one is angle, side, angle. Don't be mixed up with that, okay? So angle, side, angle, that's ASA. Beautiful. To the next question we go. So here now we are given, so this is the one, everyone gets this one, 5 and a 5 on that one, an 8 and an 8 on that one, and 9 and a 9. So clearly, side, side, side. That's a game we used to play when I was a child. Used to go side, side, side. Yes. So this question here, proven again for congruence. So let us check what we've got. So in this one, we can see we got an hypotenuse there, we've got a right angle, and we also have another side. Check on the other one, right angle, same side 5.3, and also the hypotenuse. So clearly this one is RHS. So now we are going to do another question, but this time this question asks us to prove congruence. So in the diagram, the lines AC and BD intersect at E. AB and DC are parallel. Very important information there. And AB is equal to DC. So AB, let's do that, is equal to DC. Prove that the triangles ABE and DCDE, let me take time, guys, let me take time because my eyes used to fill with water. CDE are congruent. Okay, now we just reviewed the criteria or the conditions for congruence. So when we're proving that, we need to at least show 3 things that makes this congruent. For example, if it's side, 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 if it's and so forth. So let's go. First piece of information that is very useful here is what the question told us. So they actually gave us one part of the criteria. So first thing, AB is equal to DC. So that's one thing. We know that one side, so let's just put side beside that. So we know at least 2 sides on each of the triangles are equal. Now we go back using the information for parallelism, parallel lines. Remember, when lines are parallel, then angles are formed in those lines. So I can see here this alternate angle. So the angle here, remember, angles in the Z are alternate, but we can't just do that. We got to write it out. So that means BAE, angle BAE is equal to angle C. So from here, ECD. So ECD. So that is an angle. Beautiful. Now, the other way is true as well. There's another Z here for an alternate angle. So this angle here at ABE, let's write that down. ABE is also equal to EDC. So EDC. So again, another angle there. Beautiful. So these two angles would be the same as well, but do we need them? Not necessarily at all, because we got a full criteria here already that links them. So angle, a side, and an angle. So therefore, they are congruent. Well, if we want to, we could write this one down as well. Just give all the information we know. So AEB is equal to DEC. DEC, so that's an angle again, but we don't really need that. But write down all you know. So therefore, let's write the reason as well why they are. So these are equal. So for this one, we got alternate angles. Make sure you state that. And alternate angles that made these the same. We want you to give us the reason. Without the reason, you are not getting all the marks. This question, by the way, is for 4 marks. So they are congruent. If you don't conclude like this, you have lost the answer mark as well. So they are congruent by ASA. And if you had put AAS, you would still get the mark, but the most common one to use is ASA. So they're congruent by angle, side, angle. Well done. So we move on to subject of the formula. And I don't remember if I've told you before, but there's a full lesson on that. This lesson here. Link will be in the description as well. So make D the subject of the formula. So remember, the subject always is the letter that stands on its own. So at the moment, E is the subject. So we want D to be on its own. So we need to check the operations we have in the question. So H is for have, what's currently there, and D is for do. So at the moment, beside D is a +5. We're going to need to do the reverse of that, which is a -5. We do that to both sides. So E is equal to D plus 5. We need to subtract 5 from both sides. So E minus 5 is equal to, these two 5 cancel out, leaving us with D. So D is equal to E, take away 5. Check that off. Make W the subject of this formula. So we need to check what we have in the question, what we need to do. So the last thing that happened is a minus A. We need to add A. Then the first thing that happened was multiply by 3. We always take care of the last thing first. So we are going to need to divide by 3. So rewriting that, y equal 3w minus a. I need to add a first to remove a. So y plus a is equal to 3w since the a's cancel out. Check that off. I now need to divide both sides by 3. 3 cancel with 3, so w is left on its own, and that's equal to y plus a divided by 3. Tick that off. Beautiful. Next question. Rearrange t equal w divided by 2 to make w the subject. So what we have is a division by 2. Sorry, we need to multiply by 2. So have division by 2, multiply by 2 is what we need to do. So t is equal to w halves. We need to times by 2, times by 2. So t times 2 is 2t, and that's equal to 2's cancel out here, w. So w is equal to 2t. Beautiful. Next question, make D the subject of this formula. Again, what we have is a +5. What we need to do is a -5, but we also have a multiplication by 4, so we're going to need to divide by 4. So C equal 4D, add 5. Take away 5 first from both sides, tidy up. C minus 5 here is equal to, 5's cancel out, 4D. Tick that off. Then we need to divide by 4. So 4's cancel out. So D, therefore, will be equal to C minus 5/4, or we say over 4. Final question on this bit. Make W the subject of the formula. So again, what we have a division by 6 first of all. Let's take care of that first. So A is equal to W minus 2. So over 6. So I need to do the opposite of dividing by 6, which is timesing by 6. So times by 6 times by 6. So 6 times A is 6A equal to 6 cancel out, leaving us with W minus 2. So now I have a minus 2. I need to add 2. So plus 2 plus 2. So 6A add 2 is equal to 2's cancel out W. W therefore is equal to 6A add 2. Check that off. Beautifully done. Now we go for similar shapes. So for each pair of similar shapes, find the missing lengths by first finding the linear scale factor. Kind question doesn't always tell you to do that. So remember, to find the linear scale factor, we need to match up two corresponding sides. In this case is 6 and 12. So 12 divided by 6 is 2. So the linear scale factor is multiplication. To get from this one, we have to times by 2. So now we're finding A. We're getting from the small shape to the large. Sorry. So A then is equal to 2 times by 4, which is equal to 8. And the unit is centimeters. Now we move on to similar shapes. So these two shapes are similar. So we observe them, we can see one side of the small one is 8, the height is 8, and the baseline there is 6, and 12, and x for the larger one. We're asked to work out the value of x. So we know that once it concerns similar shapes, the first thing we do is to find the linear scale factor by matching up two corresponding sides on each shape. So linear scale factor is equal to, large one is 12 divided by 8. I'm just going to use my calculator, guys. So 12 divided by 8 is equal to 1.5. So they are linked by multiplying the small shapes linear components by 1.5. So I can see here I'm going from small to large, so I need to multiply. So x then is equal to 6, which is the corresponding side on the small shape, times by 1.5, which is equal to 9 centimeters. Beautiful. Now, guys, before I forget, I've done all the series of similar shapes, similar lengths, similar area, similar volume. So you need to watch these videos here because I've not covered them here since those are already there as very short lessons that you need to watch as well. So we move on to the next one. Triangle ABC and PQR are similar, not drawn accurately. Work out the length of QR. So I'm just going to put X here just to show that that's the side I'm after. So again, I need to find the linear scale factor. So I'm going to do 16 divided by 12. Now, guys, 16 divided by 12, if you do this, you're going to see that it converts to a recurring decimal. So in a case like this, it's best to just simplify it and work with the simplified fraction when you're calculating. So dividing this by 4, common factor is 4. We will get 16 divided by 4 is 4. 12 divided by 4 is 3. So the linear scale factor is best kept as 4/3. So now we are moving from the small shape to the large shape. So therefore, I need to do that x would be equal to 15 for the side of the small shape times by 4/3. Now I will get a proper answer if I do 3 into itself goes once and into 15 goes 5. 5 times 4 now gives us 20. So x then is equal to 20. So QR is equal to 20 centimeters. Absolutely brilliant. So another similar shape, but this one is called a nested shape because two similar shapes are joined together. So by drawing both triangles separately, so this is a question that is kind again, it doesn't always tell you, but if not, you still do it. Work out the missing lengths in these diagrams. So I'm going to draw the small triangle here. The length on that is 6. So small one, 6, K, and 8. Let's draw the large one now. So to draw the large one, now be careful. The large side is 6 plus j for this side. So 6 plus j. And for here, 8 plus 4, which is 12. And then 10.5. So now I need to use two sides that matches to find the linear scale factor, which is 12 divided by 8. Again, calculator can help us with that. So 12 divided by 8, also 1.5. So therefore, I can find out what k is here. So I'm going from large to small, so I need to divide. So I'm going to divide. So k is equal to 10.5 divided by 1.5. So 10.5 divided by 1.5 is equal to 7 centimeters. Check that off. Okay, so now I need to work out the length of j. So I'm going to use the 6 here multiplied by the scale factor should be equal to 6 plus j. So let's go. So 6 times by 1.5 should give us the side that matches, which is 6 add j. So we need to work this out, and then if we subtract the 6 that we already know, which is here, the rest would be j. So let's go. 6 times by 1.5, that's 9. So 9 is equal to 6 add j. Beautiful. So subtracting 6 from both sides, I get that j by itself is equal to 3. Okay, so that's 3. And that's 7 here. You can easily put them back in and check now. 6 times by 1.5 will give us 9. So 6 plus 3 is 9. Absolutely brilliant. So we go on now. Guys, I just keep getting my titles wrong. But now we are going to look at a linear graph question. So we're asked to complete the table of values for y equal 2x add 1. So all of the values already, 2 were already done for us. So we just need to focus on the last one. So y equal to 2x add 1. So that means when x is 3, I'm going to do 2 times by the 3 add 1. So 2 times 3 is 6. 6 add 1 is 7. So the missing value here is 7. Beautiful. So now, on the grid, draw the graph of y equal 2x add 1 for the values of x from -1 to 3, which is just the values in the table. So we're going to plot them. So -1, -1. So I'm going x first. -1 to -1 is here. Tick that off. I need to now do 1, 3. 1 to 3 is here. Tick that off. 3 to 7. So 3 to 7 is here. Now remember, if we're drawing a straight line graph in the form y equal mx plus c, and we do not get a straight line, we know something is wrong. So I've pre-drawn my line in there. So we just need to label it now. Y equal 2x add 1. Beautiful. So now on the grid, part C, we're asked to draw the line y equal 5. So we go on the y-axis, look for 5. It will be a horizontal line all the way through that. Label it y equal to 5. So if it was x equal to, the line will be vertical. Don't mix it up at all. So now we're going to draw a quadratic graph this time. Complete the values for the table for y equal 2x plus x plus 2. They've done just 3 for us to fill in for ourselves. Same principle apply. So we're going to be substituting our values in and then after drawing the table. So we just need to work out -2. So let's write the equation. Y equal x squared plus x plus 2. Remember, when you're substituting your values in, put it in bracket. So x then is -2. We need to do -2 squared. Plus, we also have another -2 here, plus the 2 at the end, because x is -2. Replace it everywhere that x is. So remember, when we square a negative, it's supposed to be -2 squared. So -2 times -2 is +4. So minus 2 times minus 2 is positive 4. Okay? If you put this in your calculator without the bracket, you're going to get negative, which is wrong. So square it and put inside the bracket the number you're squaring. Then we are actually just subtracting 2 and adding 2. So a plus and a minus is still a minus. So therefore, what we're doing here is 4 plus 2, which is 6, take away 2 is 4. So we put our value here, 4. Then we substitute 1 in this time. So we have x squared plus x plus 2. We are putting 1 instead. So then 1 squared plus 1 for x again plus 2. So 1 squared is still 1. 1 plus 1 plus 2 is 4. Remember, quadratic graph, we get corresponding coordinates because it's going to make a parabola. Beautiful. Last one we need to do is x squared again plus x plus 2. We get 2 squared, because we're substituting 2 this time, plus 2 plus 2. So 2 squared is 4 plus 2 is 8. So now we got our coordinates. We move on to the next question, which says, draw this graph. On the grid, draw the graph of y equal 2x plus 2 for the values of minus 3 to 2, which they gave us here. So let's be careful. Minus 3 to 8. So this is minus 3. Observe our scale properly. So minus 3, we're going up to 8, which is here. Take that off. Minus 2 to 4. Minus 2 all the way up to 4 is here. Tick that off. Minus 1 to 2 is, so minus 1, 2 is here. Tick that off. 0 to 2 is here. 0 to 2, tick that off. 1 to 4, 1 to 4 is here. Tick that off. And then 2 to 8. So 2 to 8 is here. So now I shouldn't use a ruler to connect the points when I'm doing a quadratic because I'm expecting a curve. So I'm going to try to do it really nicely here. So we just need to go through all the points, making a nice smooth curve. Yours may look better than mine. Beautiful. So there we go. We've finished our graph and moving on. Okay, so now we go to ratios. So the ratio of red apples to green apples in a basket is 1 to 2. So red to green, 1 to 2. Okay, what fraction of the apples in the basket are red? So first of all, we need to get the total. So 1 plus 2 is 3, and we need red, which is 1 part. So part A, red is 1/3. Beautiful. What fraction of the apples in the basket are green? So green is equal to 2 out of 3. So part B, it's 2/3. So remember, 1/3, 2/3 gives us a whole, which is 3/3. So that's how we know we're correct. The ratio of blue pens to black pens, so blue, black. So the ratio of blue pens to black pens is 3 to 5. So in a box is 3 to 5. What fraction of the pens are black? Again, we need to get the total. So 3 plus 5 is 8. We want the black first. So black is 5 out of 8. Remember, follow your ratio parts properly. Easy mistakes can be made here. What fraction of the pen are blue? So blue was 3 parts. So that's 3 of 8. Nice and simple ratio question there. Moving along to another ratio question that's a little bit more challenging. So a dessert has both fruit and yogurt inside. Altogether, the mass of the fruit and the yogurt is, so altogether, everything adds to 175 grams. The ratio of the mass of fruit to the mass of yogurt is 2 to 5. What is the mass of yogurt? So first step, we need to find the total of the ratio parts. So total will be equal to 2 add 5, which is equal to 7 parts. So that 175 represents 7 parts. So 1 part of the ratio then will be equal to 175 divided by 7. So I'm going to put that quickly in my calculator. So 175 divided by 7 is 25. Okay, if it's a non-calculator paper, you would have just used your bus stop to do that. Okay, so now we want for yogurt, which is 5 parts. So 5 times 25 is equal to, so 5 times by 25 is equal to 125, and the unit is grams. So yogurt equal 125 grams altogether. Absolutely fantastico. Guys, make sure you don't forget to like the video. So now we go on to our final question on angles. So in this question, the diagram shows 3 straight lines. Work out the sizes of angles A, B, and C and give reasons for your answer. So give reasons for your answer. So we're going to be giving it in the form because. So we say what the angle is and because. So for A, we need to work this out. We know that angles on a straight line is equal to 180 degrees. So A then would be equal to 180 take away 130. Okay, so 180 take away 130 is 50 degrees. So A is equal to 50 degrees because angles on a straight line add to 180. Okay, write that out. So part B. So B, we can see faces 60 degrees. So B is also 60 degrees because vertically opposite angles are equal. Okay, are equal. Beautiful. And the last bit, C. So we have let's put A in as well. So that's 50. So C then would be equal to, remember, angles in a triangle at 180. So 180 take away 60 plus 50. So 60 add 50 is 110 degrees. So 180 take away 110 degrees is equal to 70. So 70 degrees because angles in a triangle add to 180 degrees. Absolutely brilliant. Guys, I'm actually really so proud of you for getting through this video. And thank you for your engagement in the comment section. And make sure you remember to like the video. Okay, make sure you remember to share with a friend. And also there is a new feature now called Hype. So if you look for that, where you have the like button, if you scroll across, you will see Hype. And that means you help me to send the video up in the algorithm so that other people can see as well. Guys, I appreciate you so much as a part of my community, and make sure you stay tuned. Guys, also do not just only watch the walkthroughs. You need to watch the short lessons as I post them each week, because that will take the pressure off you when you now have an exam. You're trying to learn everything at the same time, but if you revise in small chunks, you will be ready just to do a little final prep like this walkthrough now, but not all in one sitting as some people do. Until next time, guys, thank you so much for watching.